Well, let's welcome this part. In this part, we closed Unreal and reopened it, and the level we had opened and were working on, to which we had given materials, is no longer displayed for us here. First, we want to learn how to define that when we close and reopen Unreal, we see the thing we were working on. This is the first item. The next item, we want to talk about how to create a new map or level, and after we create it, how to use the things I gave you and build your own level. Let's do this together. The first item is, how do we create a level? To create a level, you just need to come up here to the File section and here click the New Level option. It asks you a question. Well, which of these should be the type of level you are creating? Empty, Basic, Open World. Now the open world that we are seeing here is what is displayed for us by default when we open Unreal Engine. We generally don't deal with open worlds. We only use these two, and it's better to choose Basic. Why? Because we removed the initial lighting process and it has considered that lighting for us itself. Well, I select Basic and click the Create button. When I do this, it creates a level for me like this. In the outliner, I can see that a series of elements have been added. I don't care about these. Now the first step I take is to save my level. Just as I explained to you before, as long as you don't save something in Unreal, it won't show it to you when you close and reopen it. Well, I come here, File, and click the Save Current option. Now it asks me, in which path do you want to save this? Don't be afraid of the different window shapes of Unreal. Generally, Unreal windows have a consistent structure. It might only be different in appearance when it pops up from the mode we are always used to. Well, like the content browser, I can select a path. I definitely want to go into Test Game Asset, and here I want to save my level or map. For saving the level and map, LLVL, we can also write it in capital letters, underscore, meaning level, and then here I enter the name of my level. What do I put here? I put, for example, Level Design. Well, this is saved now, and as you can see up here, we are now in the Level Design map. We arrive at the point where, how can we save this in a way that when we close and reopen Unreal, we no longer see that open world map? We go directly into Level Design. For this, we go to Settings, to the Project Settings section, and in Project Settings, I search for the Maps and Modes option. Well, this is it. The Editor Startup Map option must be set to Level Design. Well, I select Level Design. I come here and click this option, and that's it. Meaning if I save my project now, close it, and reopen it, this level design of mine is what opens as the start. And that's all. Okay, this is up to here. Now, before we want to enter the process of adding models and defining how to use different snaps in Unreal Engine, I want to talk to you a little bit about lighting in Unreal. I will tell you some things so that our work gets started in that level design area, and then we will go further, spend more time on it, and gain more information about lighting. I turned off the lights. I went to the unlit mode, because there is no light in the scene now, and we want to go to the process of creating light in Unreal Engine. For this, we go to the Create section, or Quickly Add, and go to the Light section. In light, there are 5 general categories. Directional light becomes the sunlight, and skylight becomes the skylight. Well, I will tell you a very small definition and pass by it because we won't use it much in this process. Directional light, which is the sunlight, is our main light source. Skylight is somewhat simulating the atmosphere of the sky for us, in this way. When sunlight comes into the Earth's atmosphere, for example, this sunlight has bounce in the Earth's atmosphere, meaning it hits objects and returns and causes some illuminations or events to happen. This skylight does that job for us. It doesn't have any specific luminosity by itself, but when you have a directional light, it comes and diffuses your sunlight. We don't care about it. We pass by it. This definition is sufficient. We have 3 other lights: point light, spotlight, and rectangular light. This rect light, spot, and point are also in other software. I will talk about them simply to give you a quick introduction so you know which options we need to change now. Let's go to adding our first light. I come here, Light, and add my point light. Well, it usually drops it in the center of the image, essentially aiming at the center of where you were looking, and drops the thing you were creating there. We cannot rely much on this. I recommend that when the work and the item are actually created, you select its actor, come into the Details section, and Transform. Now here, I set it to 0, 0, and 0. I bring it up a little, and we go to the Lit mode. Well, we see that light exists in the scene. It is being calculated. Let me tell you an important point here. The first item is about game engine lighting systems. Generally, we have two lighting systems. One is static mode, meaning all your lighting conditions are saved, stored, or as they say, baked. And then the speed, or that FPS, soars to the sky. Why? Because no light calculation happens in real time anymore. It has a good side. Its good side is that the FPS has gone up. It has a bad side. Its bad side is that our hands are tied. We cannot make many changes in real time, and trial and error are very high. The most part returns to the level design phase and the process of creating the environment and game and those stories. It has nothing to do with us. That is, we who want to create game assets or present our game assets in the game engine, we don't deal with this much, except for one case that I will explain to you in the UV section, so keep this in mind. The next item. Another system also exists which we call dynamic, meaning any change you apply, you see it in your scene in real time. This dynamic system in Unreal Engine has evolved, combined, and reached a technology called Lumen. Now, my lighting in the Unreal Engine scene is progressing through Lumen technology. I only explain this to you so that your mindset is ready. If you hear the name Lumen, or hear that, well, this is now being calculated dynamically, you know what is meant. We don't need to delve into it more than this, because it is not useful for us at all. The entire final scene we want to work on, we will do this through the Lumen system. Well, we reached the point where we brought our point light, but we don't see it now. We are only seeing its effect in the environment. Whenever this happens, press the G key on the keyboard. Then you enter a mode of the viewport where you can see the actors of the items you brought in. Well, now we can see that it has a point, which is the light source. It has a radius, which is this big sphere. And the light has more intensity from the middle, and its intensity decreases as it goes to the sides. It is a structure that I think exists in all CG software. Well, let's talk a little more about its parameters and details. In the Details section, I come here, open this gear, and say Collapse All Categories. Some of these categories you see here are useful for us. Some are not useful for us at all. The first thing that is very useful for us is Transform, which defines its position. The next is Light. In the Light section, we use some items a lot. For example, Intensity becomes the strength. Okay, so I can control the intensity of my light through Intensity. Now we can give it a unit, which we won't do. We use the same candelas, and that's all. We can define a color for it, like this. Any color we want to have in our light. Which is natural, this is possible in all software. And we can increase or decrease our radius. There is a point here. We also have three other parameters: source radius, soft source radius, and source length. What do these three do when I increase the number a little in point light? In the logic of point light, 1 pixel, 1 point from our 3D space is selected. It becomes the light source and starts emitting light from itself. You can say, I don't want this to be a point. My light volume is much bigger. My light form is much bigger. So I can come here and increase or decrease the radius of my source, which is 8 in my intensity and strength. And as we go from this yellow to this blue, that number 8 decreases until it reaches 0. Well, what is this soft? This is for when we want the shadows that this light is creating not to be too sharp. To understand it better, I add a shape from above here. For example, I put a cylinder here. Well, I increase its scale a little. I put it here. Okay, I select my light again. Let's go to this section. Okay, look, when the radius is 0, the soft radius is 0, my shadows are this sharp. When I increase the radius a little, well, the edges of my shadows become a little softer. Well, this is a general rule in the discussion of light. I don't want to get into it much because we don't care about it at all. I'm only telling you that if you wanted a soft shadow somewhere, you can use these options. And if we increase this number, the amount of softness increases. Well, what does this length do? This is a circle now, right? Sometimes we want to have a capsule shape. Well, when we increase its length, our capsule shape is actually created here, like this. It is this easy that we can create light sources of this model. There's another option too, that we can use temperature to define whether our light color is warm or cool light. It's a very useful option, and we don't care about the rest of the items for now, and the things I told you are the same in most lights. Let's test it together now. Well, we learned how to use point light, what settings it has. Be sure to practice this thing I told you yourself. Work with it a little. Since it's real time, you will easily get the hang of what is happening. I delete this light. I come here, light, and add my spotlight. I bring it up a little. Let's set it to 0, 0, and 0. We grab it from the Z-axis, bring it up, and also give it an angle, like this. Well, the big and important difference that exists between point light and spotlight is that point light diffuses light 360 degrees. Spotlight only comes and lights the area in front of itself, within the defined boundary, and delivers that light to it. Well, this is like a flashlight, and a point light source, for example, we can consider as a lamp hanging from the ceiling, because it diffuses light 360 degrees. It has intensity. We can increase or decrease its intensity. Again, we can define a unit. We can define a color for it. And this radius that you see here is exactly like what exists in point light. You can define at what distance this light is supposed to end and reach 0, and other items that are here too all help you to have a softer shadow, for example, or to be able to control the direction of your light. Generally, all the parameters here are the same as point light, only the lighting form is different, which is important, because we are going to use these. I am explaining these to you. Let's go to the next light. The next light is rectangular light. This light is exactly like the spot mode, but with one very big difference, and that is, in spot mode, you have a circular beam. You have a cross-section in the shape of a circle. The light is diffused through that. But rectangular light is like this. It is a square or rectangle that you can define its size here, and the light is emitted through that window and that square or rectangle shape, and you can control it this way. Let me give an example so it sinks in for you. Suppose you have an asset like a TV, and you want to consider an auxiliary light for it, so that it emits light into the environment from itself. You can't put a point light. That's not logical. If its reflection falls on the glass, it becomes a luminous point. It makes no sense at all. You can't put a spot either. Why? Because its cross-section is rectangular, and it's not like we say it is creating a light source from a point like a flashlight and lighting the space in front of it. So we need another light type. In such cases, we use rectangular. Rect light lights are like this. Well, they have intensity, like other lights. You can change its unit, you can change its color, it makes no difference. And you can change its radius too, exactly like point light and spotlight, at what radius the lighting should happen. Its only difference is in its shape, that you can have it as an elongated rectangle, for example, or as a square. There is another option too, called barn door angle. Barn door angle is what you see on this edge. This middle rectangle of ours becomes our light source, and this barn door, these components that exist, become the direction of the light. Now look, the direction of your light is like this. You have a light plane, and it is practically doing its lighting 180 degrees. Many times we don't need something like this, and we want to limit it. We don't want this light surface of ours to diffuse light from all angles. This is where we use this angle. If we set it to 90, well, it becomes perfectly straight. If we reduce it, you see the diffusion angle of the light is becoming more limited. Well, this is clearly showing us the light is being diffused here, and for example, it is no longer lighting up here. If we set it to 90, well, it becomes perfectly straight. If we reduce it, you see the diffusion angle of the light is becoming more limited. Well, this is clearly showing us the light is being diffused here, and for example, it is no longer lighting up here. Now, a question arises: no matter how much you increase or decrease the number, it doesn't affect the light it puts on this model. What should we do here? Here, we must increase the length of this barn door or the light limiter. If I increase this, as you can see, the light no longer exists in these areas and our main light is being emitted like this. This concludes the lighting section, where we gained an initial familiarity regarding the settings that we will work with and how each of them operates. For now, we will keep the issue at this level. We will go to the next video. Before you come and enter the next video and do the practice I want to give you there, be sure to practice the lighting discussion. This lighting discussion that I tell you to practice is because you fully understand how the Unreal lighting system works. Yeah.